Good day everyone! For today's episode, let's talk about the specific heat. This is your servants at your service and welcome to Bits Academy Season 2. Different substances react to heat in different ways. When a metal carrier is exposed to direct sunlight on a hot day, it can become quite hot to touch. The temperature of an identical mass of water in the same area or under the sun will not be the same. We would say that the water has a high heat capacity, or the amount of heat required to raise the temperature of an object. Water is very resistant to temperature changes, while metals in general are not. The amount of energy required to raise the temperature of 1 gram of substance by 1 degree Celsius is known as the specific heat. Here are the list of the specific heats of some common substances. The amount of heat gained or lost by an object when its temperature changes can be calculated by the formula heat is equal to mass multiplied by the specific heat multiplied by the change in temperature. The heat that is either absorbed or released is measured in joules or in calories. Let's have some examples. A 15-gram piece of cadmium metal absorbs 134 joules of heat while rising from 24 degrees Celsius to 62.7 degrees Celsius. Calculate the specific heat of cadmium. Given for this problem, we have heat is equal to 134 joules. For the mass, we have 15 grams. For the change in temperature, we have the formula final temperature minus initial temperature. That is 62.7 degrees Celsius minus 24 degrees Celsius. That is 38.7 degrees Celsius. And for the required for this problem, specific heat of cadmium. Let's solve. We have the formula heat is equal to mass multiplied by the specific heat multiplied by the change in temperature. By deriving this equation, we have specific heat is equal to heat divided by mass multiplied by the change in temperature. By substituting the given, we have 134 joules divided by 15 grams multiplied by 38.7 degrees Celsius. By calculating this, we have 0.231 joules per gram degree Celsius. The answer for this problem, the specific heat of cadmium is 0.231 joules per gram degree Celsius. Another example, a 500-gram block of copper is heated from 295 Kelvin to 350 Kelvin. How much heat in calories is absorbed by the copper? Specific heat of copper is 0.093 calories per gram degree Celsius. Given for this problem, we have 500 grams for the mass. Initial temperature is 295 Kelvin. By converting it to Celsius, we have 295 Kelvin minus 273.15 is equal to 21.85 degrees Celsius. For the final temperature, we have 350 Kelvin. And converting it to degrees Celsius, we have 350 Kelvin minus 273.15 is equal to 76.85 degrees Celsius. So, for the change in temperature, we have 76.85 degrees Celsius minus 21.85 degrees Celsius is equal to 55 degrees Celsius. And for the specific heat of copper, we have 0.093 calories per gram degree Celsius. The required for this problem is the heat. Let's solve. Using the formula, heat is equal to mass multiplied by the specific heat multiplied by the change in temperature. We have heat is equal to 500 grams multiplied by 0.093 calories per gram degree Celsius multiplied by 55 degrees Celsius. We have 2,557.5 calories or 2.56 kilocalories. The answer for this problem is the heat absorbed by the copper is 2,557.5 calories or 2.56 kilocalories. Now that we know the specific heat capacity of a substance, what if we need to measure changes in thermal energy or in heat transfer? Let's find out on our next episode. Once again, this is your servants at your service.